My project was making mozzarella cheese from scratch. This video shows my process as well as what's happening on a chemical level. Enjoy! These were the ingredients I used to make my cheese. Citric acid separates the curds and whey in the milk, and the chemical equation is C6H8O7. Calcium chloride replaces the calcium found in unpasteurized milk. The equation is CaCl2. The non-iodized or kosher salt helps the flavor and texture of the cheese be delicious. Its equation is NaCl. Whole milk was my main ingredient. It's made up of 80% casein proteins, which have the equation C81H125N22O39P, and 20% whey, which is an organic molecule. The rennet acts as a coagulant for the curds. Rennet is found in the lining of cow stomachs and is made of 20% pepsin, which has the equation C6H6Cl6, and 80% chymosin, which is also an organic molecule. My first step in making the cheese was adding the citric acid to the milk. The citric acid has a pH of 2.2, which is much lower than the milk's pH of about 6.8. By adding it to the milk, the overall pH lowers. Caseins are the protein in milk and are molecules wrapped into compact spheres by negative calcium and phosphate ions, which form micelles. The citric acid, as well as heating the curds on the stove, keep the pH low and dissolves the phosphate in the casein micelles, replacing them with hydrogen. This causes the caseins to unfold in a process called protein denaturing. The partially unfolded caseins are then able to interact with other caseins and clump together, making the milk look lumpy. The rennet works with the calcium chloride to further separate the clumps formed by the citric acid into curds and whey so they can be strained. The rennet works because the big molecule chymosin in rennet cuts off the negatively charged tips of the micelles on the casein. Without negative tips, the protein molecules separate from the water molecules in the milk because opposite charges attract molecules to each other, so without negatively charged tips, the two positive hydrogen atoms on the water molecules have nothing to be attracted to, making the coagulated casein appear to be repelled from the water when it stays in its own clumps. These are the curds and whey. I then use a cheesecloth to strain the whey out of the curds, so that the cheese has the right texture. I then added the kosher salt and microwaved the cheese repeatedly for 45 to 60 seconds. Protein chains of the casein formed when I added the rennet, and kneading the curds makes the chains get longer, which is how the cheese gets smooth and elastic and stringy when melted. I then shaped the mozzarella ball how I wanted it, and bathed it in a cold salt water bath to hold its smooth shape and texture. Some takeaways I had from this project were how cheese is made and how easy the process actually is. I thought it would be much more complicated. This project gave me insight into all the fascinating chemistry that happens for everyday things to be the way they are. I'll never eat cheese again without knowing exactly how the process works, which is so cool. Here are some of the sources I used for this presentation. I don't have any safety notes since there weren't really any dangerous parts of my project except maybe the stove, and I didn't eat any of the chemicals on their own. I hope you enjoyed, and I'll link the recipe in the description below.